This is the fourth video on section 6.4, gradients and directional derivatives. And so here we're going to look at two theorems and a corollary. And so we have theorem 183, that if you have a unit vector and you have a function from Rn into R, and we're going to consider the point C, the rate of change of f at C in the direction of the unit vector u is the directional derivative of f at C in the direction of u. So again, we have some form of the derivative as the rate of change. We're looking at the rate of change of f at C in the direction of u, and that is the directional derivative of f at C in the direction of u. Keep in mind, I didn't write it on the board, but u is a unit vector. And so, theorem 184, we have f as a function from Rn into R, C is in R. The maximum rate of change of f at C occurs in the direction of the gradient. That is the direction that it occurs in, but what the maximum rate of change actually is the magnitude of the gradient. I didn't write this, but corollary 185, so I didn't label this corollary 185. But this talks about the minimum rate of change of f at C. It occurs in the direction of -1 of the gradient, and the minimum rate of change actually is the magnitude of the gradient multiplied with -1. So we will look at example 186. We have a function of two variables. We have a polynomial of two variables. We want to find the rate of change of f at the point 1, 1 in the direction of 3, 4. In your notes it says 4, 5. That's a typo. Okay? So I want to calculate the rate of change of f at the point 1, 1 in the direction of 3, 4. But hold on for 1 second here. Our theorem 183 says that we need a unit vector. And so we can find the directed derivative in the direction of 3, 4, but that's not what we want. We want a directional derivative. We need a unit vector. So we're going to set u to be the magnitude of the vector, the scalar product of the magnitude of the vector with the vector. So this, u is a unit vector. The vector we're given, 3, 4, is not a unit vector. This is a unit vector, and that's what we need. So we calculate the gradient of f at the point 1, 1. So for the gradient of f, we have the partial derivative with respect to x, then the partial derivative with respect to y. Substitute 1 for x and 1 for y. So the gradient of f at the point 1, 1 is the vector 5, 2. The directional derivative of f at the point 1, 1 in the direction of u, and I see I forgot my f there. I'm just going to write that in rather than go back and redo the whole video. Let's just correct this. There we go. So we have the directional derivative of f at the point 1, 1 in the direction of u. That's just the dot product of the gradient with the vector. So we have the dot product of these two vectors. That is 23 divided by 5. Remember, dot product is always a number. The direction of the maximum rate of change of f at the point 1, 1 is going to occur in the direction of the gradient, which is 5, 2, and that maximum rate of change is the magnitude of the gradient, which is square root of 29. It wasn't asked in the notes, but the direction of the minimum rate of change of f is going to occur in the direction of -1, 5, 2. In other words, take the opposite direction of this vector for the minimum rate of change. That is the direction of the minimum rate of change. What the minimum rate of change would actually be, though, is negative square root of 29.